Hmm. So anyway, just very quick revision I'm giving you. Okay, Jaslyn, I'm just revising very quickly. So this is the chapter quadrilaterals I'm doing. First of all, we have three types of quadrilaterals. Okay. One is called trapezium. You can keep a copy and you can note down everything, right? Okay. So
Okay.
one is trapezium. The other is called parallelogram. And the third type of quadrilateral is a kite, right? Now, what is the difference between trapezium, parallelogram, and kite? So in trapezium, you know how it looks like. So basically, we have two sides which are parallel to each other. So I'm not saying they are equal, just parallel. This is the condition. And then you join it. So it becomes a quadrilateral. So if I name it A, B, C, D. So AB has to be parallel to CD. That's it. So if this is the case, it is called trapezium. Okay. Right. Now kite. In kite, what happens? Okay, first of all, in parallelogram, uh, the opposite sides are parallel to each other. So it's a figure like this. If I call it A, B, and C, D. So the opposite sides, AB is parallel to CD, right? And the other AD is also parallel to BC. So as you can see, one additional thing is there if you compare, right? So both pair of opposite sides are parallel to each other and obviously they are equal. When they are parallel, they have to be equal, isn't it? So also AB is equal to CD and AD is equal to BC. Now kite, so it looks like this. In kite, what happens? The adjacent sides are equal. So, and then this is the shape of a kite. You must have seen it, correct? So A, B, C, D. So basically this side is equal to this side and then this side is equal to this side. So adjacent sides, not the opposite. Adjacent means just connected to each other, one after the other. So AB is equal to BC and AD is equal to CD. So adjacent sides are equal. So this is kite, right? Now let us focus on parallelogram. So again, parallelogram can be of three types, right? Now what happens if all the four sides are equal? So that will become a square, right? So basically the parallelogram is again divided into three parts. I mean, there are of three types. So one is called a rectangle, correct? Then you have a rhombus and then you have a square. So you can make this chart to make things clear in your mind. Now what happens in rectangle? See, now these criteria has to be fulfilled in all the three figures now. So that is fulfilled. As you can see, a rectangle looks like this: A, B, C, D, right? Then a rhombus looks like this: A, B, C, D, and then a square is this: A, B, C, D. Sorry, write it like this: C and then D. No, how I was writing. Okay, make it same both. Okay, I'm just naming it same way to avoid confusion. So A, B, C, D. So A, B, C, D, and then A, B, C, D, A, B, C, D, same way. Okay, now as you can see in all the three figures, AB is parallel to CD, right? This is fulfilled. And AD is parallel to BC. This is also fulfilled. Again, AB is equal to CD in all the three figures. And then AD is equal to BC. Now, so how do you differentiate between rectangle, rhombus, and square? So in rectangle, the opposite sides are equal. So AB is equal to CD, right? And AD is equal to BC. Now in a rhombus, all the sides have to be equal. So AB is equal to BC is equal to CD is equal to AD. In square also, all the sides are equal. So AB is equal to BC is equal to CD is equal to AD. Now what is the difference between rhombus and square then? So there's an additional thing that this angle has to be 90 degrees. So any one of the corner angle, let me say angle D, that is 90. So if one is 90, all the other are going to be 90. That I'll explain later, right? And also in rectangle, because it can look like this also, isn't it? So this is not a rectangle. In rectangle, again, same thing. One of the corner angle has to be 90 degree. So this will be called simple a parallelogram, not a rectangle. Understand? In rectangle, this thing also has to be satisfied. In a square, this thing also has to be there. Right, Saf? Okay. So now you know what is a parallelogram, right? Opposite sides. Let me just write properties of a parallelogram very quickly. In short, I'm writing parallelogram. So the first property is the diagonals. See, I've already actually done this exercise, so I'm just mentioning it. I'm not doing any derivation now. That we will see later. So diagonals of a parallelogram divides it into two congruent triangles, right? That means if you have any parallelogram, it can be a square, it can be a rectangle, rhombus, any parallelogram it can be. And let's say this is the diagonal. So this is AB and CD. So according to this property, this upper triangle, that means triangle ABD, will be congruent to triangle this CDB, correct? Okay. Now second property, opposite sides are equal. Right? Sorry, equal. So in this parallelogram, opposite sides are equal. Third property is opposite angles are also equal. Right? Opposite sides are equal, opposite angles are equal. Then you have a fourth property. So this is again important to remember. Any two consecutive angles of a parallelogram are supplementary. What is the meaning of it? If you have any parallelogram, A, B, C, D. Consecutive means just one after the other, right? So A and B are consecutive angles. A and D are consecutive angles, right? So that way. So you take any two consecutive angle. Let me take this angle A and angle D. So angle A plus angle D will be 180 degrees. So this is the property of a parallelogram. Understand? Or we can also say that angle A plus angle B is equal to 180. That is also true because A and B are also uh, consecutive angles. Fine, Saf?
Yes.
Okay. And now the last one property, that the diagonals bisect each other. So again, important. What is the meaning of this? If you have any parallelogram, A, B, C, D. So if you draw a diagonal, this, right? Now the other diagonal will divide this into two equal parts. Understand? So AC will divide BD into two equal parts and BD will divide AC into two equal parts. So OA is equal to OC and OD is equal to OB. This is the property of a parallelogram, that the diagonals bisect each other. So these are the 5 properties. And today I'm going to start the midpoint theorem, which is second exercise of NCERT. Yes, Jocelyn, can you hear me?
Yes, ma'am.
Okay, so that was a very quick revision of the properties. Hamna, why are you here? Your class is over now. You can leave. Okay, first of all, write down, then I'll explain the meaning of it. And you have to do the proof also. So the line segment joining the midpoints of any two sides of a triangle is parallel to the third side and is equal to half of it. Please write this down, then we will understand its meaning. Okay, written? Yes, have you written?
Yes.
Okay. Now let us understand the meaning of it. So if you have any triangle, so let's name it ABC. Now read the line. So the line segment joining the midpoints of any two sides of a triangle. So you choose any two sides. Let me choose AB and AC and mark the midpoint. So let's say E is the midpoint of AB and F is the midpoint of AC, right? So the line segment joining the midpoint. So that means they are talking about this line segment. Understand? EF. So this is the line segment which is joining the midpoints of any two sides of a triangle, okay, is parallel to the third side. So that means EF, according to this theorem, your line segment will be parallel to BC, right? And is equal to half of it. And this line segment EF will be half of BC. That means the third side of the triangle, right? Understand the meaning of the midpoint theorem?
Yes.
Okay. And it's true, like from every side, it's true. Again, roughly, let me explain. If I choose another pair, A, B, C, so let me take the midpoint of BC. Let me call it anything R, right? And let me take the midpoint of this. Let me call it S. So if you join this, so now this RS is going to be parallel to AB, the third side, right? And then this RS will be half of AB. Understand? Yes, Jaslyn, understand?
Yes, ma'am.
Okay. So let us do the proof because its proof also comes in exam. Let me draw it again here. Okay, this is the triangle I have drawn, and let marks the midpoint and make a line segment. So A, B, C, and E and F are the midpoints. So what is given? First of all, you write down. So E and F are midpoints of AB and AC respectively. This thing is given. And then you have to prove that this EF will be parallel to BC, right? And EF is going to be half of BC, the third side of the triangle. Understand? Okay. Now for that, you have to do one construction here. So the construction is that see, now through C, we draw a line such that this line has to be parallel to AB, right? You can draw a line segment line like this. Can we draw this? Right? It's a line going like this. And then this I join here, I extend it, and this point I'm calling D. Is that clear? Draw a line at C such that this CD will be parallel to AB. Understand? So I have drawn it like this. Now let us do the proof. Now look at this. Now I have AB is parallel to CD. Why? Construction. I have done the construction like that. Clear? And we say that AC is transversal. Can you see this thing? You have two parallel lines and then you have a transversal, right? So this angle will be equal to this angle. What kind of angle they are? Yes, who will tell me what kind of angle they are? What is the name of these angles? Jesslyn, please unmute your mic quickly.
Yes, ma'am.
Yeah, this angle and this angle. What should I call them?
Alternate.
Exactly, alternate interior angles, right? Alternate means this is your transversal AC, right? So one is on the left side of the transversal, other is on the right side of the transversal. So that is why they are called alternate. And interior means they are between the parallel lines. So both are between the inner side of the parallel line. So interior angles, alternate interior angles. So angle 1 is equal to angle 2. You can call it your result 1, equation 1. Okay. Now you take these two triangles in triangle AEF. So this triangle I'm taking and CDF. Understand? In triangle AEF and triangle CFD. I am trying to prove that these two triangles are congruent. Understand? Right? Okay. So three things. What can I write here, Jaslyn? So first of all, I can say angle 1 is equal to angle 2, which I have just proved. Right?
Yes.
Okay. Then what else I have here?
E and
See, it is given. Something is given. F
E,
is,
EF is
yes, F is the midpoint of AC. So I can say that AF is equal to CF, right? Okay. And what else? Okay, what about this angle? Angle 3 and angle 4. Are they equal?
Yes.
Why?
All vertically opposite angle.
Vertically opposite. Very good. So they are vertically opposite angles. Okay, this was given. So whenever you have an X of lines, so this two will be equal. They are called vertically opposite. And this will also be equal to this. Again, vertically opposite. So as you can see, there's an X of line here, right? AC and ED, they're cutting each other. So angle 3 is equal to angle 4. So I can say by ASA criteria, right? Angle and the included side and then again angle. So by ASA, we can say that triangle AEF is congruent to triangle CFD, right?
Yes, ma'am.
Okay, so by CPCT, now I get, okay, so one side AF and FC I've already used. So the other remaining sides are now equal from CPCT. Understand? So the remaining side is what? AE will be equal to CD, right? And the other side, which is EF, this will be equal to FD. Understand? See, what are the two other sides of this triangle? This side was remaining and this side was remaining. Understand?
Yes,
So
ma'am.
these two we can show equal from CPCT. So now I have shown them equal. Now what will I do? Now if you look at the quadrilateral now, so in 1 minute, just 1 minute, my OneNote has collapsed. Yeah, is my screen visible now?
Yes, ma'am.
Okay. Okay, now let us look at the quadrilateral. So we can say, okay, thus in quadrilateral, see, I'm calling it quadrilateral, not parallelogram. I don't know whether it's parallelogram or not, but I can see it has four sides, so I'm calling it a quadrilateral. So this is E E B C D. Can you see that in the figure? E B C D.
Yes, ma'am.
Okay. So in this quadrilateral, now let's see what do we have. Okay. So mm, see, something I can conclude from here as AE is equal to CD, right?
Yes, ma'am.
Okay. And also your AE was equal to BE, isn't it? Because E is the midpoint.
Yes, ma'am.
So from here, can I say that BE is also equal to CD?
Yes, ma'am.
Yes?
Yes, ma'am.
Okay. So in this quadrilateral, now I have this side. BE is equal to CD. That means one pair of opposite side is equal. Understand?
Yes, ma'am.
Okay. And also your side BE is parallel to CD. Why? Because whole AB was parallel to CD and BE is a part of it, so it is also parallel to CD. Understand? Saf, understood?
Yes, yes.
Okay. So from here, like from these two conditions, there's again a theorem from first exercise that if only one pair, okay, I'm not saying both the pair, only one pair of opposite side has to be equal and has to be parallel. So two things, if they are satisfied, then we can say it is a parallelogram, right? So this is the theorem that if one pair of opposite sides are equal and parallel, so then it is a parallelogram. So I'm writing in bracket so that you remember. So I'm using this theorem. Okay. So from these two, I can say, therefore, EBCD is a parallelogram. So now, instead of quadrilateral, we can call it a parallelogram. Is that clear? So again, the figure is not visible, so that is why I'm just drawing it here. So that was the figure, right? So now this is a quadrilateral. So I used this side and this side. Now because it's a parallelogram, so the other pair is going to be equal and parallel. Is that clear?
Yes, ma'am.
Okay. So that implies that the other side, which is BC, now it will be parallel to ED, correct? And also BC is going to be equal to ED. Is that clear?
Yes, ma'am.
Okay. Now, if you see this result, that EF was actually equal to FD, right? So this can be written as BC is equal to, now ED can be written as um, half of, mm, okay, can I write it EF and plus FD? Can I write it like this? Yes? The whole side ED, I mean this complete side, I'm writing EF plus FD. Any problem? Sef, any problem here? You can mark this as result number 2. So now from result number 2, I can see that EF is already equal to FD, right? So I can write BC is equal to half of, so EF and plus EF. Can I write like this? Because EF is equal to FD. Is that clear? So BC is half of, and this becomes 2EF, correct? No, some mistake I have done. 1 minute, 1 minute. You have to prove half of EF. Oh, sorry. Just 1 minute. Okay, now you one by one let us see. So now because it's a parallelogram, so the one pair, the other pair which was remaining, now BC will be parallel to ED and BC will be equal to ED. Is that clear so far? Right?
Yes, ma'am.
Okay. So now one by one let us see. From this condition, BC is equal to ED. And we know that EF is equal to FD from result number 2. Right? So this ED can be written as uh, mm, mm. I should get half of EF, right? Okay, just 1 minute. So I get okay, that's fine. Sorry. I think I was doing right. So BC is now ED can be written as EF and plus FD. Is that correct? I think you will understand it better this way. Is that correct? I'm just breaking this side ED into this EF plus FD, right? Now EF is equal to FD. So I can write BC is equal to EF and plus FD also I'm writing EF, right? So BC is equal to twice of EF and then you take this 2 in the denominator. So half of BC is equal to EF and that you have to show. Or you can say that EF is half of BC. So one thing you have already shown that this line segment is half of the third side of the triangle, correct? Now you look here, BC is parallel to ED. So when this side is parallel to this complete side, so that means it will be parallel to a part of it also, isn't it? So this implies that BC is also parallel to EF. Understand? So the two things you have shown that the line segment EF is parallel to BC also and is equal to half of BC also. Is that clear? Please write it down. Jaslyn, have you written?
Yes, ma'am.
Okay. Now the converse of this theorem is also true. Please write converse of midpoint theorem. Now what will be the converse? So again, if I draw a triangle, now the converse proof will not come in the exam. Okay. You just have to understand the meaning of the converse. That's it. Theorem proof, I think it will not come this year. You can leave the proof. I just wanted to show you how I get it. Otherwise, understanding of the theorem is important here. Is that clear?
Yes, ma'am.
Okay. Please write the statement. The line drawn through the midpoint of one side of a triangle parallel to another side meets the third side at its midpoint. Please write, then I'll explain. Now, what is the meaning of converse? Now, what were we saying earlier? So earlier I was saying already that E is the midpoint, right? And F is already the midpoint. So E and F were already the midpoint, right? And what was the conclusion? The conclusion was that the line segment EF will be parallel to BC. Is that clear? So in the theorem, we were saying this, right? Now in the converse, what I'm saying is that only one midpoint I have taken. Let's say E is the midpoint of AB. So the line drawn through the midpoint, that means we are talking about this line. Understand? EF. So the line drawn through the midpoint of one side of a triangle parallel to another. So we are already saying that EF is parallel to BC. So this thing is given this time. Is that clear? In the theorem, this was the result. And in the converse, this is the given thing. So EF is already parallel to BC. Then what is the result? So the result of this converse is that F is the midpoint of the other side. Understand the meaning?
Yes, ma'am.
Okay, meets the third side at its midpoint. So this is the difference. In theorem, both are already the midpoint, and we say it is parallel to the third side. In converse, it is already parallel to the third side, and one midpoint is given. So F is the midpoint of the other side. That is the result. I hope you have understood now. Let us start with exercise 8.2 now. Just 1 minute. Let me open it in my book. See, the solved examples are very, very important for exams. Please practice them. And if you're not able to understand, then we can discuss in the class. Just let me know. Okay, just give it 2 minutes. Read the question. Give it 2 minutes to understand. Yes. Have you read? So what is it saying? ABCD is a quadrilateral, right? In which PQRS are the midpoints. Okay. And AC is a diagonal. Now show that SR, that means this side, is parallel to AC, that means this, right? And SR is half of AC also. So one by one, let us see. So first of all, what is given that you write? So P is the midpoint of AB, right? Q is the midpoint of BC. Now R is the midpoint of CD and S is the midpoint of AD. This is given. Then first part to prove. So you have to prove SR is parallel to AC and SR is half of AC. Right? So let us do the proof. Okay, now if we look at the triangle ADC, in triangle ADC, right? Now what is happening here? So it is already given that S is the midpoint of AD. Understand? And this side R is the midpoint of CD. So we can use midpoint theorem, right? Okay. So from midpoint theorem, we can say so when both are the midpoint, so therefore we can say that this line segment SR will be parallel to the third side of the triangle, that is AC, and SR will be half of AC. So that's it. That's the proof of part 1. Yeah, written.
Yes, ma'am.
Okay, second part, you have to show that PQ is equal to SR, that you have to show. Now where is PQ and where is SR? All right, so this is PQ, this is SR, as you can see, right? This is SR, this is PQ. Okay, so in part 1, what we have just shown, so we have shown that SR is parallel to AC, already shown, right? And also SR is half of AC. So let us call it result number 1, already proved in part 1. Now, if I take the lower triangle, that is ABC. So in triangle ABC, again, it is given that P is the midpoint of AB, right? This is given. And also it is given that Q is the midpoint of BC. This is also given to us. So again, from midpoint theorem, we can say so when both are the midpoint, so that means we can say that this line segment PQ is parallel to AC. Is that clear? And the line segment PQ is equal to half of AC. Can we say that? Let me call it my result number 2. Right? Now, if you compare the result 1 and 2, so first of all, look at this. SR is also equal to half of AC and PQ is also equal to half of AC. So what can we say? From 1 and 2nd, first of all, we can say that SR is equal to PQ, right? I think that's it. Only this much we have to show. That's fine. Okay, now third part, we have to show that PQRS is a parallelogram. So that means one more thing we can show here from result 1 and 2. That will help us in part 3. Now you can see SR is parallel to AC and PQ is also parallel to AC. So can we say that SR is also parallel to PQ? Yes, Jesslyn. Why can I say this? I told you in the last class also. See, it's not an equation, it's not algebra. So I cannot say like this that SR is parallel to AC, PQ is parallel to AC, so SR is parallel to PQ. No, it's with the help of a theorem I'm saying it. Now, what is the theorem? In the chapter lines and angles, you must have done. So if you have 3 lines, let's say, Seth, are you here? Okay.
Yes, ma'am.
So now understand, if you have three lines, let's say L, M, and N, right? So if your line M is parallel to line L, if your line N is parallel to L, so if this thing is happening, that these two lines are parallel to the same line. So the theorem says that the two lines are parallel in itself. Understand? So this is the thing I'm using here. Both are parallel to AC. So I'm saying that SR is also parallel to PQ. Is that clear? Okay, now this will help us in part number 3. So in part 3, you have to show that this middle PQRS is a parallelogram. All right, now look at the figure. So in previous parts, what we have just proved, that PQ is equal to SR, right? In part 2, PQ is equal to SR. I have just proved. Is that clear? Right? And this, I have also proved that PQ is parallel to SR. Is that okay? Now in this quadrilateral, one pair of opposite side is equal and parallel. Therefore, it's a parallelogram. Understand? So in quadrilateral PQRS, right? We can say that one pair of opposite sides are equal and parallel. Therefore, PQRS is a parallelogram. It's a theorem, okay? Steph, do you have any question to ask?
No.
Okay. Just feel free to ask if you want to ask something. Jaslyn, any problem here?
No, ma'am.
Okay. See, I'm doing one thing. Because question number 2 and 3 are a bit long, I'm taking question number 4, right? And then in the next exercise, I'll take up 2 and 3. Let's do fourth one quickly. Okay, see here. ABCD is a trapezium. So whatever is given, first of all, write it down. ABCD is a trapezium, so it is given that the side AB is parallel to DC. Can you see that? AB and DC in the figure? Okay. BD is a diagonal, okay, and E is the midpoint of AD. So this is also given that E is the midpoint of AD, right? A line is drawn, okay, a line is drawn, sorry, through E parallel to AB. that means this line EF is already parallel to AB. This is also given. So 3 things are given, 1, 2, and 3. Intersecting BC at F. Show that F is the midpoint of BC. To show F is the midpoint of BC. Okay. Let us do the proof here. Let give this point some name where it is intersecting. Let me call it G, right? Now, if I take triangle ADB, can you see that? In triangle ADB. Yes?
Yes.
Okay. So we can use midpoint theorem here. Why? Because E is the midpoint of AB, correct? Already given. This thing is given to us. Okay. Now, this whole EF is parallel to AB. So this complete side is parallel. That means a part of it will also be parallel to AB, right? So we can say EG is parallel to AB. Why I can say? Because the full line EF was parallel to AB. That's why. So I can use the converse of midpoint theorem. This line is already parallel, right? So from the converse, I can say that G is the midpoint of BD. By converse of midpoint theorem, I can say that G is the midpoint of BD. Is that clear? So at least I got this midpoint. So G is the midpoint. Now, if I show that GF is parallel to DC. Now look here, what exactly I have to show? I have to show that F is the midpoint, right? That means this F is the midpoint. So in this triangle, again, I can use the converse, right? So to use the converse, I need 2 things. The first thing, that G is the midpoint of one side, I have already got, correct? Now I need GF parallel to CD to use the converse. How can I use it?